this is Unit 9, Lesson 2, Graphing Inverse Variations. And don't worry, there is no live audience here today. All right, so what we're going to take a look at is graphing, like I said, inverse variations. All of these graphs are going to have numerical numerators. We will take a look at tomorrow what happens when we have it be have a variable in the top and the bottom and a polynomial, and how that might affect our graph as we go along. All right, so this is kind of just an introduction. So the first one, we're just going to look at two examples. The first one is going to be y equals 1 divided by x. So right now we don't really know much about these, so let's go ahead and set up a table of values to figure out what our points look like, and then in the future as we understand the pattern, we can just use that to help us graph. All right, so we're just going to use kind of some basic numbers, and I'm centering it around the origin because this is the parent function because there is no values being added or subtracted, so I know it's probably not shifted sideways. So that center of the graph will be the best location to look at. All right, so my function is just 1 divided by x. So I'm just going to go through and put pretty much 1 over x. So if x is -3, y is -1/3. When x is -2, y is -1/2. All right, I have -1. Now what happens if I do 1 divided by 0? Wait a minute, I can't do that. You can't divide by 0. If you try in your calculator, it will tell you error. If you ask Siri, she'll make up some really crazy story. So we're going to put a dash there for right now. All right, and we'll come back and talk about what that looks like on the graph. So I have 1 divided by 1 is 1, 1/2, and 1/3. All right, so let's go through and let's plot those points and just do the best you can with the 1/3 and 1/2, okay? So I'm going -3, -1/3, -2, -1/2, -1, -1. And then I've got 1, 1, 2, 1/2, like that. So that looks kind of funny and not quite sure what it should look, well, I do know, but not sure, yet what it should look like. Well, let me show you. First of all, we know that the graph is never going to touch the y-axis here because I'm never going to have an x value of 0. So this part, if I look at my points on the left side over here, I notice they're kind of going down, so my graph is going to look something like this. Okay. That little down drop, it's never going to touch the x-axis. Okay, so I can get really, really small decimals there, and it's still never going to give me, I can get really small x values, but I'm never going to have an x value of 0. I can have an x value of -0.000001, but that's not 0. As it's moving off to the left, no matter what my x value is, as it's getting smaller that way, it's never going to give me a y value of 0. Okay, because if I plug in -20, my y value is -1/20. If I plug in -200, my y value is 1/-200. So no matter what, I'm never going to have a y value of 0 or an x value of 0 in this parent function. So the other chunk of my graph is going to look like this. Same thing. It's going to approach x and approach y. So we do just our best with graphing it. It's not going to be perfect. Just make sure that it's not crossing over those x or y axes. Okay, and we're going to put in some other lines on here that's really going to help us in the future with that. Okay, so my zeros, well, it's not crossing the x-axis, so I don't have any. So I can put none for now. Now, please do keep in mind that that's not always going to be the case. It kind of just depends on where my graph is. We'll take a look at us shifting it around later, and we might have zeros in the future, so we just have to be mindful that I'm not always going to have none there. Okay, so if I don't have any zeros, I also don't have any x-intercepts. And I see it's not crossing y, so I don't have any y-intercepts. All right, here's our new vocabulary, asymptotes. That word is pronounced, once again, asymptote. Okay? So we have a vertical asymptote and a horizontal asymptote. So what are asymptotes? They are lines on our graph that our graph is approaching but never will touch. So once again, they are lines. So my vertical asymptote is actually going to be this vertical line right here. And we always indicate it on our graph by drawing in a dashed line. Okay, because that is the vertical line that both chunks of my graph are approaching but never actually touching. And when I'm asking you to identify what the vertical asymptote is, I'm asking for the equation of a line. Think back to your Algebra 1 days, and vertical lines are x equals. Okay, so what is that x value? 0. That's the number that if I were to substitute into the original equation would make my denominator undefined. Okay, think back once again when we were simplifying rationals. Those are the restrictions that that x value is your restriction. A graph will never, ever, ever, ever cross a vertical asymptote. All right, so if a vertical is an x equals, your horizontal line is, change colors here, a horizontal line that the graph is approaching. Now, and we will see this future, not today, but your graph can cross the horizontal asymptote. That's okay, because you can have, it be equal to 0. It's just more of the horizontal asymptote is going to help us with our end behavior. It's kind of more just like what's happening, not in the middle of the graph, but at the ends. Okay, that's the value that the end arrows are approaching. So we will see graphs future on when your horizontal, that will cross the horizontal, but they won't ever cross the vertical, because that's what would make our denominator undefined. So that's a bad no-no. So here my horizontal asymptote is y equals 0. All right, now the rest is just some review. Woohoo! Increasing, decreasing. Keep in mind that your increasing and decreasing are your x values. We're saying between which x values is a graph on an upward trend or a downward trend. So if I take a look at this, it's feeling very colorful, and I trace this, I'm going down the whole way. Okay, it's kind of just going down a little bit and then it really increases. But that whole chunk is on a downward trend. So I'm decreasing from negative infinity to 0. Hey, notice that's my vertical asymptote because the graph stops there. It doesn't actually touch 0. And then if I look at the other portion of my graph, it's also decreasing. If I were to trace this, I'm going down, 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 down. Now, it's not going down as drastically here, but it is still going down. So that's decreasing from 0 to infinity. No, you cannot simply write from negative infinity to positive infinity because you have that little chunk missing in the center of your graph. So we need to account for that asymptote. All right. And did we have any increasings? No. Now, something I like to say, take it or leave it, but your increasing, decreasing always deals with your asymptotes. Sorry, with your x values, okay, which is your vertical asymptotes, your x values. So when you're writing your increasing or decreasing, the value you're going to end up using is always from your asymptote. So you can just go ahead and pull it out of your asymptote there. All right, my end behavior deals with our y values. So once again, that asymptote is going to help us. So we can just reuse that information. Okay, so end behavior. Now, you'll see a bunch of different arrows here, but we're not talking about the relative end behavior, which means the arrows in the middle of the graph. We're talking about literally just the ones at the end. So I'm dealing with these. And we'll at another time talk about how we can analyze the arrows in the middle. But for right now, I'm talking about those and how do I know? Because that's what's being asked. It's asking me as x is approaching infinity and x is approaching negative infinity. Here's where it's approaching positive infinity. Here's where it's approaching negative infinity. So as the x is approaching positive infinity, what y value is that graph getting closer and closer and closer to? 0. It's never, the end's not crossing the horizontal asymptote. Okay, and same thing on the left side, it's approaching 0. So once again, I can just pull it out my asymptote. That number is going to help me with my end behavior. The vertical helps me with my increasing, decreasing, the horizontal with my end behavior. All right, domain and range, what x values appear on this graph? Well, everything except for my asymptote, right? So there's a couple different ways you can write it, but we can just say it's going to be the real numbers. So XER, X is an element of the reals, but it doesn't equal 0. Okay, so you can write it that way. You can write it as two inequalities like we did for the decreasing intervals. Either way is fine. So once again, that value, this number, comes back to our asymptote. YER, where y does not equal 0. Okay, so anything that's dealing with our x values is the same as my vertical asymptote, okay? And anything with my y values is my y asymptote. All right, we're going to take a look at the next example. If you need to pause the video, please do so. So in this one, we're transforming it, we're moving it around. I find it the easiest when you graph these is to actually sketch on those asymptotes first. It kind of just helps you make sure you don't cross on crossable lines and stuff like that. And it gives you a good focal starting point, kind of like that vertex is part of the graph. All right, so x plus 2. Think back to our days of transformations. It's with the x, so it's sideways, so in the opposite direction, to the left 2. So my vertical asymptote is going to be not at 0, but to the left 2 at negative 2. So I'm going to go ahead and dash that line in. And we might as well write that equation now while we're at it. X equals negative 2. my horizontal asymptote is going to be up 3. Okay, so just like with transformations, anything moving sideways is with the x, anything on the outside is your vertical. So up 3 at positive 3 and dash, dash, dash it in. Okay, y equals 3. Now to go ahead and graph it, I'm going to go ahead and just, if you remember back on this first one, our main point was simply 1, 1 and negative 1, negative 1. So I'm just going to copy that from, not the origin, but kind of like treat that as your new origin where those two asymptotes cross each other. So they're crossing here, so over 1, up 1. And then from there, it's going to be kind of like down and like up. And then same thing, from where they're crossing, over 1, down 1. So here. Now, if you have a numerator that's like a 2 or a 3, you do have to keep in mind a vertical dilation. So you would just have to go like over 1, up 2 if there was a 2 on the top, or over 1, up 3 if there was a 3 on the top, as opposed to a 1. So bringing back all that transformation stuff. All right, so we do have zeros and y-intercepts at this time, and they don't look like pretty numbers. So how can we find that? Well, to find out where it's crossing x, we're going to plug 0 in for y and solve. Oh no, math. You can do it. All right, so first things first, I'm going to subtract 3 on both sides. Okay, clear that denominator out. We're multiplying both sides by it so I can move it over because I'm trying to solve for x. So I've got negative 3 times x, which is negative 3x. Negative 3 times 2, which is negative 6, equals 1. Solve for x, add 6 to both sides. It'll be 7, and x equals negative 7/3. So that is my 0. And then the intercept is just writing that as a point. All right, now to find my y-intercept, we're going to plug 0 in for x and solve for y. And scooch down. So I've got y equals 1 over 0 plus 2 plus 3. And when you do that math, you get 3.5. So my y-intercept is 0, 3.5. Okay, in terms of decimals and fractions, it doesn't matter to me. The way I do it is if it's a clean decimal like 0.5 or 0.25, I just write it. If it's a repeating or ugly decimal, I write it as a fraction. I just find that cleaner. So, all right, increasing, decreasing. Well, it's not increasing anywhere, right? Increasing, I'm going down. And it's decreasing from negative infinity. Remember, use the same number as your asymptote to negative 2. And then negative 2 to positive infinity. That is this part right here, from negative 2 to positive infinity. It's on a downward trend. It's not increasing at all. End behavior. Pulled out your horizontal asymptote. It's 3. Okay, this arrow is approaching 3. Okay, for a y value. It's never getting there. It's getting closer and closer. This arrow is approaching 3. It's not getting there, but closer and closer. Domain, what x values do I see? I see everything but the negative 2, because that's my restriction here. All right, and for my range, I see everything but 3. All right, we are done. Go ahead and try the practice. Check your answers, and we'll be doing more of this next class as well. Bye-bye.